Welcome to Ms. Taylor's class notes. So today we're going to talk about transformations and how we can tell that shapes are congruent. So if we kind of look at the examples we have here, for them to be congruent, they have to have the exact same size and the exact same shape. So all three of these figures, all of the sides are the exact same and they make the exact same shape. Whereas here, these are not congruent because they are completely different figures. These three are all congruent. So one way for us to tell if shapes are congruent is to figure out how many or which rigid motions map them onto each other. So again, two geometric figures are congruent figures if and only if there is a rigid motion or a composition of rigid motions that maps them onto the other. So what we're going to do for this lesson is we're going to use all of our transformation rules that we know so far, translations, reflections, and rotations, and we're going to see if we can find a rule that maps them onto each other, which proves that they are congruent. So if we look at this example here, I'm kind of looking for shapes that are congruent and which transformation I can use to prove they're congruent. So I know CD. I know that this shape is 2 by 2 and this one's 2 by 2. So I need to figure out which rule. So I'm always going to try translations first because those are the easiest. So if I do my vector notation, so if I map CD, ABCD onto NQR, whatever that shape is, we went down 1, 2, 3, 4 to the left 2. So that would be a transformation of X comma Y. We went to the left 2, which would be X minus 2 and Y minus 4. And so that works. So we know they are congruent shapes. So now I'm going to look at triangle EFG, and it's 2 and 3, which means it's going to be congruent to this one here because it's 2 and 3. Now, F and L would be the corresponding points. So I'm wondering if it was reflected. So if I look at point F, it's 1, 3, negative 1, comma 3. So if we reflect over the x-axis, my rule is x, comma, negative y, which means this would be negative 1, negative 3. So that would work. So for those two, we used our reflection rule, which is x, comma, negative y, and that was reflect over the x-axis. And then finally, we've got our last two shapes. So we've got a triangle with 2 and a triangle with 2. I and T are going to be the corresponding parts. So how are we going to get I and T? Could we maybe have rotated it? So if we rotated it, that would have been 180 degrees. So let's check our 180 degree rule. So I is 1, 2, 3, 4, 5, negative 5. 1, 2, 3, 4, 5. T is 5, negative 5. So if we look at our 180 rule, it's negative x, negative y. And so the negative, so we could have rotated 180 degrees for that one because we made the x negative and it became positive. We made the y negative and it stayed negative. Or I wonder, could we have also reflected it across of x over y? Because our rule for x over y is we flip the x and y. Or we could have done y comma x, which would have been a reflect of y equals x. So either one of those would have worked, and really at the end of the day, they're pretty much the same rule. So what we just worked on was we worked on congruence transformations. So we had to figure out the rigid motions or the congruent transformations that happened to get us from one shape to the other. So let's look at some more and let's figure out how we can do it and how we can make it work. So if we're looking, one of the big things for us to pay attention to is direction. So ABCD is the pre-image, or it's the first one, and EFGH is the image or the last one. So we're going in that direction from that one to that one. So the way it's written is I want my A to line up with my E is how I want to do it. So if I need my A to line up with the E, the first thing I'm probably going to do is I'm probably going to reflect it over the y-axis. So if I reflect it over the y-axis, this would get me A prime, and then B is 1, 2, 3 away. That'd be B prime, D is 2 away, and then C is there. Nope, C is there. C prime. So now that I'm looking at it, to get A to F, I just need to translate it 1, 2, 4 down. And that would get everything where it needs to be. So my two transformations would, 1, be reflect over the y-axis. Oh, why are you doing that to me? And then my second rule would have been to translate down 4. And so that would be a congruence transformation. Now, as we kind of discovered on the one above, sometimes there are multiple ways that you could do this. You could have also translated first and then reflected over the y-axis, and you still would have gotten the same way. I'm trying to think, could you have rotated? I don't think you could have rotated, because if we needed A to F, I don't think you could have reflected diagonally, but there are more than one ways to get the answer. All right, so I want you to work on this one on your own and see if you can come up with similar. Actually, no, there's not a lot left with these notes, so I'm going to do this one with you as well. So again, we start with JKL and we go to MNP, and I need J to become M. So let me think about this. So J to J to J. So I don't think rotation would work, because I think that would put J right there where P is. So rotation's not going to be our best friend on that one. But I could transform it down. But no, I don't know if that's going to help me out, because then I would need to get K over there to N, and it would be in the wrong. So I bet I need to reflect it over the x-axis. So let's try that first. So if we reflect over the x-axis, that puts J prime there, that puts L prime there, and that puts K prime there. So if I have one reflect over the x-axis, and then, yep, it's just an easy slide, 2, 3, 4, 5. So it's a translate right 5 for rule number 2, and we get there. So these are two theorems I want you to be aware of. We're not going to spend a lot of time on them. But if we know that lines K and M are parallel, and we reflect across K, and we reflect M over M the same way, that's the same thing as translating from A to B. For this one, if K and M intersect at P, and we reflect over K, and then we reflect over M, it's the same thing as a rotation. Again, those are just two theorems. We're not going to spend a lot of time on them, but those are two that we have for this unit.